wonder if you could discuss what brought you together. What was the intersection of your thought processes when you met? How did that manifest?
I think there's a lot of things to unpack here. I think the first thing I said when we met was, what is active inference? And it snowballed from there.
I would say it's all in the title. It's about integrating action and inference. So inference as cognition or computation, getting broken down into kind of an inbound perception-like aspect, and then an outbound action selection-like aspect.
Like Daniel mentioned, the core tenet is this duality between perception and action, and the core idea behind active inference is that both of these processes can be cast within the same mathematical and computational framework, which is approximate Bayesian inference. So both updating your internal model of the world as you're receiving sensory input can be modeled as a process of approximate Bayesian inference, and the only thing that you're really optimizing is the minimization of uncertainty.
Hey, Daniel and Jakub, it's great to have you here.
Thanks for having us.
Of course. As always in this series, I like to start at the beginning and get a sense of who you are. I'd like to ask each of you if you could share where you're from, where you grew up, where you're currently based, and if you could give a brief overview of your professional background.
Hi, I'm Jakub. I'm originally from Prague, Czech Republic. My background is in math and physics from undergrad, and currently I'm based in the Bay Area pursuing a PhD in applied physics at Stanford.
Cool. All right, over to you, Daniel.
Thanks. I'm Daniel. I'm a researcher in California. Grew up here and also living here now. And was in KB5 and continued with some projects there and with friends there and elsewhere.
Cool. And how did you two first meet?
That was when I was in KB7, but prior to that, I was in the DeSci space, and Daniel and I got connected when we were both in this project on applying active inference to construct an ontology for decentralized science. So I was in a decentralized science DAO working on simulations of different incentive structures for decentralized science, and randomly I found myself on this other project that Daniel was spearheading.
Yes, that was through Shadi, and Jakub was doing some of that simulation work, and that was the interesting question in that DeSci phase, whatever it was in 2022, whatever it is now, with just what are the internal and external motivations, incentives, constraints, possibilities for learning and action. How is that all going to get synthesized, described, analyzed, built to at least enable the possibility of there being function, let alone sustainability or a regenerative or productive aspect to any epistemic ecosystem, whether it's just a book club or it's traditional legacy academia, or whether it's research projects and communities of practice that have morphologies that haven't been seen before.
Cool. And I think it would be helpful context if one of you could define for us active inference.
I'll go first, but Jakub, please. I would say it's all in the title. It's about integrating action and inference. So inference as cognition or computation, getting broken down into kind of an inbound perception-like aspect, and then an outbound action selection-like aspect. And those are classic ideas. They've been explored in everything from systems theory and cybernetics to end-to-end training in machine learning, robotics. So the territory is the one that we're already in terms of physical spaces and cognitive systems. And a lot of the maps and tools already exist. And active inference is an emerging approach or thematic unity that helps model those systems.
Cool. I like that. Jakub, do you want to add anything?
I think that summarizes it very well. Maybe to add just some more words to the definition. Like Daniel mentioned, the core tenet is this duality between perception and action, and the core idea behind active inference is that both of these processes can be cast within the same mathematical and computational framework, which is approximate Bayesian inference. So both updating your internal model of the world as you're receiving sensory input can be modeled as a process of approximate Bayesian inference, and similarly the process of selecting your actions to exert change on the world to get into states that generate observations that are already in line with your world model can be cast in the same way. And that's really why it is a unifying framework, because these two things in other fields are usually cast as slightly different processes, or they're not necessarily unified under a common ontology.
And my understanding is it's rooted in this unifying principle of minimizing free energy. And I wonder if you could, both of you, talk a little bit about that and how that's connected to active inference as well.
I think there's many layers, from the exoteric and technical and specific to very subtle, so it's always interesting. One way to approach this is maximizing reward or how well a model fits. Another way to frame that is minimizing surprise. Like if you were minimally surprised by the next incoming temperature reading, it's equivalent to saying you would have fit it maximally well. And while there isn't a tractable, heuristic, incrementally optimizable way to guarantee that you're improving reward, but you can use gradient to approximate it, but there isn't a guarantee about that. You can bound surprise using these approximations. And because those information theory approximations look like a lot of things that were being explored in thermodynamics, it has inherited a free energy term, and that's what's used in variational autoencoders. It's called an evidence lower bound, and there's a lot you could say and explore from there. And there's a lot more physicalist and thermal entropic interpretations and connections as well. But just on a first pass level, it's an informational quantity which you can write open source software and calculate and interpret very legibly. And it's bound on surprise, so that even when you can't exactly compute surprise itself, there's this more well-behaved, approximatable informational quantity. And so by bounding surprise, you're pushing up the high bar on model fit, asterisk, 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 by pushing down the surprise bound.
Anything you want to add, Jakub?
I think that summarizes it very well.
And then to the DeSci context, it's like a new stimuli is presented, whether it's a blockchain node receives a new block, or whether it's a person checks the user interface for a wallet app and they see something, or it's a social message through a language channel, or it's like all these different kinds of communication, message passing, interfaces, surfaces, screens, blankets, something pings in, something changes on the boundary. There's some sense-making internal change ranging from unattended to, which is to say it didn't happen for that individual, all the way on through extremely impactful. And then that cognitive impact could have some actionable outcome or not. It could change what the next outcome is likely to be or not. So active inference gives us all the knobs and the expression tools to just really sketch that out. Super practical settings and super fantastical imaginary settings. So the framework doesn't say anything about anything in specific, Just like English doesn't tell you how to design your room or make a safe highway or something like that. But if it can be understood for what it is, as an expression toolkit for those kinds of situations and their composition, then it has all of this utility.
I wonder if you could talk about the collaborative work that you did together in meeting one another, being involved through DeSci. You've penned a few papers together. I wonder if you could discuss what brought you together. What was the intersection of your thought processes when you met? How did that manifest?
I think there's a lot of things to unpack here. I think the first thing I said when we met was, what is active inference? And it snowballed from there. The first project that we collaborated on was the DeSci/active inference paper, which was a project in collaboration with Upstream, which was the DAO that I was contributing to at the time, and the Active Inference Institute. Then following that paper, Daniel and I were discussing different ways of actually operationalizing this framework in different computational instantiations. At the time, I was working on the simulations for modeling incentive structures in DeSci. And one core question there was, could you use agent-based modeling to verify different DeSci ecosystems that are centered around smart contracts, have autonomous agents, try out different things, and develop a map of how that ecosystem works and can evolve over time. And discussions around how we might do this with agents that behave according to active inference, not just with fixed rules, but something similar to reinforcement learning agents, but instead of having some explicit reward function, the only thing that you're really optimizing is the minimization of uncertainty. That sparked the follow-up project that Daniel and I collaborated on called Active Blockference, which took some of the existing work in agent-based modeling for tokenomics and some work that I applied to DeSci, to the DeSci ecosystem modeling, but added the active inference spin on top of it. Follow-up work was also in the same realm. How do we make this process more systematic? How do we design active inference agents, active inference simulations, and then turn them into executable programs automatically, which was the GNN work that we did together.
I'll give a slightly alternative account there. First, one of the delightful background projects through Kernel, which was begun by Sid and others who also joined for the DeSci paper, was DeSchool. Some just want to see the world learn. And it was a really fun weekly type rhythm with Jason Ma and others at Kernel. So that's the this is not a department. And within that, not a department, Jakub was a very enthusiastic intern / co-learner as an undergrad. And we just met in a group project, continued to want to work asynchronously in the time between that. And then after we land the plane on that group project, let's see what questions are exciting for us. All these different ideas about language systems and expression and notation systems, and a separate document shared with us that had just more thoughts and writing, the ability to like tag each other in and just develop these different ideas. I forget the original acronym, but it was funny acronyms, funny memes, sharing useful stuff, and then continuing to work on a few things, throwing out some open source artifacts. For example, applying for a grant on cognitive auditing for hypercert ecosystems. I can say it wasn't the perfect or the complete grant, but the point is we still get to have a publication and a foothold mentioned, and just so I just cherish it as a fun co-learning with open source as well as invisible artifacts, and just reflecting those times.
I love that. You alluded to the GNN work that you did. I wonder if you could ground us in the impetus for that work. and any adoption that has happened since you guys wrote that paper?
It was 2023, and we're just seeing, wow, people are writing all these prose papers. What about attention and memory, anticipation, regret, narrative? It's like, cool. But then the gap between the prose, which is laden with kind of core active inference ontology terms, as well as just accessory assertions, the gap between the prose and the formal representation can be great and not without ambiguity. And then going from equations to executable code can also be a huge step. Like, it's one thing to say, we're going to have this neural network, and here's the equation that describes it with all these subscripts. But then to actually render that and let alone train it, again, there's more steps just from writing the equation. We were thinking, okay, how do we have structured approaches, plain text, open source, for using a reproducible approach to defining these generative models? What are the state spaces? Like, what are the sizes of the variables? Are they integers? Can they be decimals? What are the operations? So what is it? What happens to it? And that was this generalized notation, GNN, because we realized, it's not even that we really want to describe every model like a generalized notation. We just need to notate a system for describing that. And so it's a little bit memey, but then it was latent for a year or two. We had done some early LLM experiments with pasting the paper into chat and then saying, oh, okay, that's interesting, it works. But then in the last 6 months or so, I've done a ton of work on it, and a few more people have gotten interested because there's so many new opportunities for the structured generation of these compliant programs. So that's opening up a lot of possibilities with natural language description of generative models. Like, describe a baseball game, every single thing happening as a state space model. Now, that's a recipe we can't cook today, but eventually we're going to expand our recipe specification set greatly further. And then which recipes we can at least assess the costs and benefits of cooking within. It's like a recipe writing language that has been taken to a high degree, and the infrastructural work following and ongoing is making subsets of those recipes reproducible, renderable, visualizable, executable.
Cool. And is this being done in tandem or with the Active Inference Institute? I wonder if you could talk a little bit about the institute itself and its goals.
Sure. That gap between the prose and the executable code or the realization, upstream of that tool need is education. And the rate limiting step, whether it's interpreted in terms of human or more than or different than human educations, rate limiting step in learning and applying active inference is actually learning active inference. So in 2020, 2021, with some colleagues, we started what was then the Active Inference Lab, became the Institute. It's a 501c3 nonprofit organization in the US, and we do participatory science activities, create different artifacts and programs and partnerships, research fellows, internships, all these different ways that people can contribute and get involved with the ecosystem.
And does that touch your work with DeSchool at all?
They were co-inspirational, I would say. And DeSchool is like the bigger sector. It's an academic federation, but it's not either of those things per se. But who are the peer organizations and activities in the open participatory science space? But DeSchool is probably even more general, as our document and journeys and Slack channel and kernels attest to.
Got it. That makes sense. I wanted to come back to, and me and you, Daniel, talked just a little bit about this before you jumped on, Jakub. I wanted to talk about this idea of active inference as it applies or doesn't to art, because that is my background. And there was something specifically that came to mind. So there was this short-lived music discovery platform in Web3 called the Doper. two of its co-founders were neuroscience PhDs, and they talked about this idea of familiar surprise and this kind of bounded surprise of listening to music. And what they found was that when they were analyzing music and the Billboard charts, they found that the high performing songs featured increased levels of harmonic surprise in the sections preceding choruses and lower levels of harmonic surprise as tension is released in the choruses themselves. And that, of course, came to mind in context with this idea of the free energy principle and this minimization of surprise. And I'm wondering if you could explore the application of active inference to art broadly, but maybe specifically through the lens of this example.
I'm just trying to think how to approach this. Maybe if you have any thoughts, Daniel, just jump in.
Enculturation and inheritance, ranging from what are more biologically grounded on through what are just happenstance in someone's life, set up cultural expectations or scripts or norms, expectations, like the tension building before a chorus and then the sort of simple harmonic anthem like chorus or just the time signature. We're getting auditory stimuli in. And if it was exactly the song that you know, if we're listening to a metronome or it's exactly the exact one, then you can think of that as like the surprise level. Even though there's changes in the volume, the surprise level is basically flat because it sounds exactly like it is expected to. And that's actually how attention filters out 99% of our incoming information. And then, then something different. There is a violation of expectation, whether it sounded erroneous or sounds novel. But in the limit, it gets out of the Goldilocks zone because it's too unpredictable. And then unless someone's like, no, I'm the kind of person who expects to be listening to noise sounds, to which myself and my friends are confused by. So then at that narrative level, they could be bounding surprise. So again, that just shows how it's an expressive framework for talking about what is the expectation. What is this listener's preference or expectations about the structure of songs, about harmonies that are taboo or beautiful? And then what is their experience with this genre? What do they know about short stories? What do they know about detective short stories? What do they know about just these short stories? And then kind of zooming within that semantic territory, what are their attentional dynamics and their belief updating and their surprise? And then how does it relate to their action? Do they hit the like button? Do they send a token? Do they listen to it again? So then what is the actionable consequence of their perceptual surprise?
Yeah, I think the result of the research is that people were happy with these bounds of surprise within that type of music. And then that was the commonality across those musics that was inciting those actions. But yeah, curious if you have anything to add, Jakub.
I think there's some really interesting questions that open up from this discussion, or that at least came to mind. One question is, how do you actually quantify the surprise of a musical piece? Maybe you start with just quantifying the number of listens, number of unique listens per month. Maybe that can somehow quantify at least, okay, this many people like this song and they listen to it this frequently. And then the question might be, why? And is there some information theoretic description of the audio signal, or let's say the rhythm or the harmony, that can somehow correlate across songs and across these data sets of how many people listen to it and how often? And this might be one direction towards the analysis of what is the role of surprise in an enjoyable piece of music, and what do these metrics tell us about the internal model of the person that enjoys that particular type of music, because there is a vast number of genres and some tend to be more popular across a wider domain, some tend to be much more niche, but there's also varying degrees of satisfaction with a song. maybe the song that is enjoyed by everyone is not necessarily loved by everyone, but the song that is not enjoyed by everyone might have a really core fan base that enjoys it to a much higher degree than the other songs. One way of describing this is maybe each person has a unique context that they're interpreting the songs in, but I think it's important that we first narrow down on the question that we want to answer, and then find the things that we can actually measure, which might be some spectral analysis of the audio waveforms correlated with these metrics. I think there's quite interesting questions there to be unpacked.
Yeah, I think so too. It's incredibly complex and is really rooted in expectations and experience that an individual has with music. In this particular example, I think how they were quantifying it is saying that these chords that were inciting surprise were statistically rare, at least relative to what you might see during the chorus themselves, which I assume are less statistically rare, like more common chord progressions. So I think that's how they were breaking it down. But I think it opens up a broader question of our predilection for novelty, especially in something like art. And I think you mentioned it, Daniel, at the beginning, is this black room problem. If we want to minimize surprise, why do we go to museums to look for things that we want to be surprised by, or go to films and that's our desire? How does that fit in?
Again, a ton to say on that. One can be conforming absolutely to being that kind of person who seeks out a certain kind of novelty that often gets modeled with nested models or hierarchical models. Then there's the epistemic value and the value of expected information, which is like, to reduce my uncertainty about what word is on page 12, I'm going to take the action to open to page 12. But how can that be bounding surprise when it's pursuing novelty? It's because it's reducing uncertainty, but that's just about the known unknowns. So that's just one quadrant. And I think that's where the real essence of art comes into play, is in understanding that even if you whack-a-mole every known unknown, you're still only in that one streetlight, what William Blake called Newton's single vision. It's just known unknowns as they appear to you in a moment, but it's happening within this imaginarium space that's so much broader than what any given cognitive system, like a team or a person, can assess as a known unknown. And that there's an unknown that's spatially like a niche that surrounds the known that can't just be whack-a-moled away.
Interesting. Anything you want to add to that, Jakub?
How's your music playing going?
It's pretty well. Or I guess I'm not sure whether that question was directed on me.
Sorry, are you playing music?
Oh, I do play the violin and the guitar. Not at all professionally, but just for subjective enjoyment.
Aesthetic pleasure. Cool. Yeah, I feel like there's all kinds of rabbit holes that you can go down, especially at this intersection. If only we had more time. But I want to ensure that we do have some time to talk a little bit about what you have both been doing recently over the past couple of years, let's say since you last collaborated on the pieces that you're writing. And if you could talk about the work that is most important to you at the moment, and then part of this new series is really grounded in the pursuit of amplifying you guys, your projects, and rooting out ways in which Kernel can support and meet you wherever you are with the work that you're doing that is important to you. So if you could talk about individually what work you're doing and where you're experiencing any challenges that Kernel could support.
For the past 2 years, I have been a full-time PhD student. My time is mostly spent on research. For the past year or so, I was working on analyzing learning dynamics of this particular class of deep learning models called deep state space models, which is a project that I've been recently wrapping up, and been starting another project broadly in uncertainty quantification through a Bayesian lens of deep learning systems. So I've been outside of the loop in terms of Web3 recently, perhaps my work is a little bit out of context right now.
Oh, fair. But if there's nothing that really would be useful at the moment, even beyond Web3, are you experiencing any challenges in your work that could be supplemented by kernel support? And if not, great.
It's along the common thread in a lot of my work, and especially since the work in Web3, is the minimization of uncertainty, as I guess that's the game that everyone's playing. But right now, the work that I'm doing is mostly focusing on understanding deep learning through the lens of Bayesian statistics. So the key problem that I'm really excited about is how do we quantify uncertainty in the models that we train? How can we calibrate the models better? When ChatGPT gives you an answer, each token has a discrete probability distribution over tokens. And each token has a certain probability, and we usually take the maximum probability token and from that generate the entire sequence. Of course, you can add stochastic parameters to it as well. But it turns out that, for instance, these language models are often not particularly well calibrated to the accuracy of the tokens that they output. As in, if you measure accuracy on a downstream task, that is not necessarily well calibrated to the probabilities of the tokens that the model produces. I think that one of the core challenges in actually building better calibrated models, and this isn't necessarily only exclusive to language models, but rather deep learning models in general, basically models where we have minimal supervision of what the model is learning, is understanding on a distributional level what the model learns and try to identify regimes when the model is out of distribution and figuring out measures of exactly that.
Cool.
But what about the technical part? To your question, I would say I still check in with Kernel, have done some mentorship and stayed connected with some people. I'd love to see the DeSchool and DeSci project / umbrella be welcoming and productive and effective for the projects of all. And if people are interested in open source code development or science, education research service, or some of these art wavelengths, there's always more than enough to do and join in on. But I really do always return to the horse being before the cart and having there be real practice and people and care upstream of some kind of incentive or tokenomic design motif. And so that is where Kernel is always a home and an inspiration for me, because it is, at least as I see it, aiming towards that, right, orienting, and just seeing that a real community of trust can always flip out and play with multiple techniques, but a technique-driven approach is monolithic until it breaks.
I wonder if you could talk. I spent a decent amount of time going through DeSchool and the various modules and values, and I thought it was really interesting. My parents were both elementary school teachers, and conversations at the dinner table were like about the achievement gap and its consequences. I wonder if you could talk a little bit about where DeSchool is at the moment, and what's the vision for it if you had all of the resources that you needed for, let's say, 3 to 5 years. I thought some of the concepts of proof of play and proof of curiosity, and even something like the learn to earn or earn to learn approaches were really interesting. I wonder if you could contextualize those ideas within a grander vision of DeSchool.
I was only a short-term volunteer there. Didn't make those curriculum pieces for Kernel. DeSchool is like a little, it was like the side education for the people who want to party at the party, but it's like learning at the learning. And the how to resource it, what to do. Again, it's the biggest collection of learners in the world. It's everyone. there's nothing to be done. But then there's everything to be done. So what is everyone's vision? But then what is the way to move forward with education? Making open source materials that are accessible, rigorous, applicable, having some islands of professionalisms that keep that high reliability and integrity so that the tide can raise all boats and that everybody can be welcomed into a customized, caring, situation-specific, age, context-appropriate learning experience. And just like hot and cold water on the tap, be able to adjust that pragmatic and epistemic value and respect the beauty of learning and the art and the science of it as well, and where it can be made useful and re-enter into the abundance for all, then let's do it. But where it isn't, that doesn't devalue it.
Totally. Beautiful. I love that. The hot and cold water in the tap. I feel like that's a good spot to pause for now, guys. Really lovely to chat with you. I really appreciate you giving me an excuse to learn about active inference and free energy and all of the above. It was a lot of fun. I'm going to continue learning about it. Thank you for your time and your energy and your presence.
Thank you.
Thank you. See you around.
Absolutely. Take care.